0, 1 prime subtraction operation. So what is the meaning? It is the prime subtraction operation. So what does that mean? So for example, we have the numbers like 4, 9, 6, and 10, and we can do the following operation. So for this first number, which is 4, we're gonna minus or we're gonna subtract prime number. So for example, 4 minus 3, it's gonna be 1. And for this 9, we're gonna minus a prime number. So maybe 9 gonna minus a 7, so it is a 2. What about this 6? So this 6 can minus a 3 or 2 or 5. But if 6 minus a 5, it is 1. It is not in increasing order, but we need to make it in increasing order. So maybe 6 just need to minus a 3, so the result is going to be 3. For this 10, it need to minus a 5, so it's going to be 5. So this is going to be the final result, 1, 2, 3, 5. Yeah, so it's going to be strictly increasing array. Yeah, so this is a strictly increasing after all those operations. So this is possible, so we're going to return a true. So according to my explanation, you might know how to solve the problem. We just need to know which number is a prime number, and then we're going to minus the maximum possible prime number if we want to make it in increasing order. Yeah. So first of all, let's just check all the prime numbers. So we're going to define a function. I'm going to call it e prime. And the prime number, I'm going to define an array. So 4 times 2 plus true times n minus 1. So this is the Aristotle's algorithm to find all the prime numbers inside an array. So for I in range from 2 to n plus 1, if this is a prime number, I'm going to use a loop j in range I times I to n plus 1 to a step of I. So I'm going to set the prime numbers j, which is going to be false. Now from here, we can check the prime numbers. So I'm going to call the e prime function, and it's going to be 1000. So this is because the maximum number is 1000. So we just need to prepare a 1000. Now we can use this array to find all the prime numbers. So it's going to be I. So for I, I'm going to use a boolean value for I b in enumerate the primes if b means this boolean is true. If this bool is true, so I'm gonna find all those prime numbers, and then I'm gonna use the greedy idea. So for example, this 4, I'm gonna use the greedy idea to minus a number to make it as small as possible, right? Because this is the first number. I need to compare with two numbers. So for example, this is 4, this is 9. But for this 4, I need to reduce it to the minimum number to 1. But how can I reduce it to 1? I need to prepare another number to compare. So basically, this is a padding. So for nums, I'm going to prepare a padding 0 because any number is going to be more than 0. So it's going to be 0 plus nums. Yeah. Now I'm gonna loop through the nums. So for I in range, I'm gonna start from the second number. So it's gonna be starting from 1 to length of the nums. Now I want to check this number. So for example, the first number I have a padding. So for example, for here I have a padding 0. So I'm gonna compare this number 4 with this number 0. Yeah. So I want to reduce this number 4. How can I reduce it? So this means for this array, I need to reverse it, because according to the greedy idea, I always try to find the maximum prime number to check if that is possible. If that is possible, I'm gonna reduce this number. Yeah. So for this number inside the array, if nums I minus n is more than, because it is strictly increasing, I minus 1. This means I can update the nums I. Yeah, if that is possible, if for this number I minus a number, this number is gonna be the maximum prime number. If it is still more than the previous number, so definitely I want to reduce it, reduce this number. Yeah, And after reduce, because I can only do one operation, so I'm gonna break it. So finally, I'm gonna return the length of the nums gonna equal to set of length of the set of nums, and also it should be in increasing order. So nums gonna equal to sorted nums. Yeah. Now let me just run it to check if it works. Yeah, it didn't work. Let me check. Yeah, I don't know. Let me just print out this array to check why it didn't work. I think it should work, but it didn't work because I forgot to return the primes array, because this is function I needed to return an array, and from here I didn't have a return. That is why it is a non-type. Let me just run it again. Now as you can see it works. Now let me just submit it to check. As you can see it passed, and I think the speed is okay. So the time complexity for here, this is ON, N is 1000, and for here this is another ON solution, and this is ON, and this is another ON. So I think the time complexity gonna be N square. Yeah, maybe the prime numbers from 1 to 1000 may be smaller, but let's just check it as N square. Yeah, this is gonna be the time complexity, and N gonna be just to 1000. Yeah, so basically while we're analyzing it, so for this nums array it is 1000, but how many numbers, if the length from 1 to 1000, how many prime numbers, we are not sure. Maybe 500 or maybe 100, we are not sure, but let's just check it as N square for the time complexity. I think that's all about it. Thanks for watching. See you next time.